So our topic today is measuring of mass. So here the definition of mass. What is the definition of mass? The amount of matter contained in a body is called its mass. For example, if we are considering a box, we already know the objects are, that means molecules are arranged right now. So if we are counting this one, the number of molecules present in this particular box will be equal. It is not going to be changed. Suppose if I am considering this duster is having some number of molecules, and this is made up of that much number of molecules. Suppose if it is 100 molecules are there, that 100 molecules will remain there as it is. So we can say that is called the amount of matter. Amount of matter means the amount of or the number of molecules present in that particular object. Okay. So the definition of mass is the amount of matter present in an object is called mass. And we can say that mass, since the mass is related to the number of molecules, this is a constant quantity. This will not change. For example, if I am telling that my mass is this much kilogram, my mass is not going to be changed. My mass is not going to be changed. Then we used the term mass in physics, but generally we use that word weight in everyday life. Is it not? Mass is there, but normally we are not using mass. Normally we are not using mass. Normally what we are, which word we are using? We are just using weight. Is there any difference between this mass and weight? Mass and weight. Already mass definition we have seen, the amount of matter contained in a body. The amount of matter contained in a body or the number of molecules present in one particular body is called mass. But weight means actually it is the amount of force. We know gravitational force is there. Have you heard about that word? Yes. Because of gravitational force only the foods are falling down, or the stone what we are throwing is coming back, or the ball what we are kicking is coming down, is due to the force of earth or the gravitational force. So if I keep a ball at a height, this is ground level, if I keep a ball at a particular height, suppose if I leave this one, suddenly it will fall down. That means it will come to the earth. So weight is the amount by which earth is having one force of attraction towards it here. So how much amount of force is attracted by earth? How much amount of force is striking on the ball is called weight. Okay? So mass and weight are two different quantities. Weight is the force by which earth attracts a body towards its center. If you want, you can just note out. Weight is the amount of force by which earth attracts a body towards its center. It's not given in your textbook, but you have to keep it in mind. Normally, when we are measuring, we are using that word instead of mass. We are using weight. Instead of mass, we are using weight. Normally, when we are going for shops and all, you are buying 1 kilogram vegetable. You are buying 1 kilogram vegetable. Actually, we are measuring that mass. But we will never say that 1 kilogram, or instead of that one, we will never say that 1 mass or 2 mass vegetable we will not use. Is it not? Instead of that one, we can say weight. 1 kilogram weight we need. Normally we are saying that one, but mass and weight both are entirely different terms. Okay. Then again, the SI unit of mass. Now leave this one, weight, that we will discuss later. But you have to keep it in mind that the weight is the force by which earth attracts a body towards its center is called weight. Okay. Now SI unit of mass. What is the SI unit of mass? SI unit of mass is kilogram. SI unit of mass is kilogram. And here we have to keep it in mind. Kilogram means small letter. Kilogram. So SI unit of mass is kilogram, and it is represented by again small letter kg. Clear? This is the SI unit of mass. Then again, the common multiple and submultiples are there. What is multiples? Multiples are the higher units which is higher than SI unit kilogram. Normally this is kilogram, means 1 kilogram is equal to SI unit. Okay, so if it is 1 quintal, how much kilogram will come if it is 1 quintal? 100 kilogram will be equal to 100 kilogram will be equal to 1 quintal. 1 quintal. Then 1 quintal is the multiple. 1 quintal is the multiple of the SI unit of mass. That means multiple means always bigger than SI unit. Submultiple means always lesser than SI unit. Then what will be submultiple? Kilogram. Smaller unit is gram. Smaller unit is a gram. Gram is a submultiple. Normally GM we will write. Gram is a submultiple and this one is a multiple. Multiple means higher unit than SI unit. Submultiple is a lower unit than SI unit. And again we are having milligram is there. Milligram is there. This is also one of the submultiple. Okay. And after quintal, one more is there. 1 metric ton. That is what is 1 metric ton? 1 metric ton means 1 metric ton will be equal to 10 quintals. 1 metric ton will be equal to 10 quintals. Okay, so three things we have discussed here. SI unit of mass is a kilogram. SI unit of mass is kilogram. And this is second point we are having two multiples. That means bigger units than SI unit. One is a quintal. Quintal means 100 kilo. Okay, then next one is a metric ton. Metric ton means 10 quintals. Okay, then these two are the multiples. Then we are having two submultiples are there. One is gram and next one is a milligram. Normally we know 1000 gram will be equal to 1 kilogram. Okay, so this is a smaller unit than SI unit. I hope you understood this much. Okay, now next one, heavy masses are measured in quintals and metric tons. And it's normally when we are measuring the heavy objects. Sometimes when we are the farmers now, after reaping the wheat and all, they will be measuring in quintals. Okay, sometimes they will go for quintals or sometimes they will go for the metric ton also. Okay, and the lower weights, that means normally we can say when we are going for buying 1 kilogram sugar or some vegetables, fruits, and then we will use a SI unit. Okay, then again, next one we have to, already we have discussed about the SI unit and the multiples and submultiples. Next topic we are measuring or when we are using how we are going to measure mass. How we are going to measure mass. How can we measure mass? How we are going to measure the mass? Which object we are using? Beam balance. Have you heard about beam balance? Or have you seen beam balance? Page number 25, figure 3.10. Page number 25, figure 3.10. Have you seen that one? Look at the text, open the textbook. Page number 25, figure 3.10. The top figure, that is called a beam balance. Okay. Okay, a simple beam balance is consists of a straight beam of a metal. That means this is going to have a straight beam of a metal. Okay, then after that, supported at its center with the help of a iron loop. That means using an iron loop. From the center there will be a support will be there, an iron loop. That means the length of both sides will be equal. The length of both sides will be equal and the weight of the both or the mass of both sides also should be equal. Okay, then what is the next part? Two identical pans are suspended at equal distances from the center. That means from here. That means this, if this is of 1 or the 50 centimeter, this also will be 50 centimeter. At equal distance, what will happen? There will be a small pan will be suspended. A small pan will be suspended. Okay? Then the thing we have to notice is that both the pans should have equal weight. Both the pans should have equal weight, and we will use iron chain we will use in order to suspend this one. Okay, the iron chain also will be about this for the material, whatever be the material. Sometimes people will be using thread also, that is not applicable. According to the law of measurements, we have to use iron chain, and this chains also should have a equal weight. Okay, then only they will have a proper balance. Okay, so there will be, what is the construction of the beam balance? A simple beam balance consists of a straight beam of a metal. Then at the middle there will be a pointer will be there. I think you can, you have seen, I'm sure that you have seen, a pointer will be there which will be just swinging to both sides. Swinging to both sides. You have watched it now? the pointer will be there which shows left and right deflection will be there. Okay, and when we are telling that 1 kilogram, when the pointer is at a sharp at a middle. Okay, then again a pointer is fixed at the center of the iron loop. Two identical pans are suspended at equal distances from the center at the two ends of the beam. And the length and mass of the strings used to suspend these spans are also equal for both sides. That's what we have discussed. The length of this one, the span which is suspended, the length of this chain, both the 3 plus 3, 6 chains are there, and these 6 chains will have same length and same weight. Same length and same weight or same mass. Clear? And the span also will have same size and same mass. Okay? So these are the construction. An iron bar, a pointer. Normally a pointer will be at the middle. And at the extreme end we are going to suspend two pans using chains, and chains should have a equal length, equal mass, and the pan should have a equal size and equal mass. Up to here it is clear. So when we are freely suspending this one, the pointer will be sharp at the horizontal. That means the pointer will be showing like this, so that we can say that, or if you want to just before taking a measurement, if you want to just make sure that whether this beam balance is accurate, whether the beam balance is accurate or not, what you have to do, without any material on the pan, you just hold it or just suspend somewhere. If this pointer is showing sharp at the middle, then we can say that this beam balance is perfect. This beam balance is perfect. And if you are not keeping anything here, and if this pointer is showing a small deflection to right side or left side, this is having an error. It is not an accurate machine. This will have an error. Clear now? So when we are buying something from the shops and all, we have to make sure that the shopkeeper, sometimes the shopkeepers will be always keeping that 1 kilogram or 1 kilogram or 2 kilogram iron bar there itself. Okay, and if it is more than 1 kilogram, we cannot recognize, but because we are not seeing whether this pointer is at the middle or not. Okay, so like that, the shopkeepers, shop people, sometimes they will, if they are very crooked, sometimes they will cheat you. Okay, so this is that. So how we are going to measure the mass using this beam balance? Suppose I have gone to a shop and I need 1 kilogram sugar. 1 kilogram sugar. So first thing what we have to do is we have to make sure that beam balance is perfect. So what we will do, without keeping anything, we will just watch the beam balance, and if the pointer is sharp at the middle, then we can say that the beam balance is perfect. The next step, you are going to keep a 1 kilogram iron bar. You might have seen that one. 1 kilogram, 2 kilogram, 500 gram, like that. The picture is there on page number 25, figure 3.11. Have you seen that one? 500 gram is shown there, 1 kilogram is shown there, and 2 kilogram iron bars are shown there. Okay, so like that 1 kilogram iron bar, they will give the 1 bar. Okay, at that time what will happen normally? This fan will be going down. That means the pointer will be deflecting to this side. Right? The next step what we will do? We have to measure the weight or the mass of the sugar. So the person will be keeping sugar on this other part. He will be just adding the sugar up to when this pointer is already this side, up to when this pointer is coming at the middle, straight upside. Okay, so if the pointer is at a straight, then we can say that both pan will have equal height. Both pans will have equal height. Then we can say that this is of 1 kilogram of sugar. This is the 1 kilogram of sugar. And if the pointer is towards this side, the sugar is not yet 1 kilogram. And if the pointer is coming to this side, the sugar is more than 1 kilogram. Clear? Clear? So this is the method how we are measuring the mass of an object. This is the method by how we are going to measure the mass of that any object. Then a beam balance works on the principle that when two bodies with equal mass are placed on the two pans, they secure a state of horizontal balance of the beam. That means this pan will have a horizontal balance, okay, and the beam or the vertical balance, equal height, they will have a balance, so that the pointer will have a horizontal position. The pointer will have a sharp horizontal position. This is the principle of beam balance. There is a question is given. What is the principle of beam balance? So you will note that one. A beam balance works on the principle that when two bodies with equal masses are placed on the two pans, they secure a state of horizontal balance of the beam. Then horizontal balance of the beam means this is also a beam bar. This is a beam. This will be also having a horizontal balance. Then again, an accurate beam balance has the following features. What are the features given in the textbook? Both the pans must of equal mass. Already we have discussed that one. Is it not? Both the pans should have a equal mass. Both the pans should have a equal mass. Then what is the next one? Both the arms must be equal length. Arms means this one. Both the arms should have a equal length. If this one is 50 centimeter, this one is 52 centimeter, means this balance is error. It is not an accurate one. It is having some error. You will not get the exact 1 kilogram. Clear? So second one is that both the arms must be equal length. The next one, both the pans must be suspended with the strings of equal length and mass. The strings should be equal length and mass. Already we have seen. Then final, when the pans are empty, the beam should be horizontal and the pointer vertical. That means when the pans when we are keeping nothing on the pan, this beam should be horizontal like this, straight line, horizontal, and the pointer should be vertically upward. Vertically upward. If this is the condition of the beam balance without any object on the pan, we can say that this is 100% accurate. This is 100% accurate. If in case it is not horizontal, if this is not a parallel line, this is coming to this side or this side, this is having some defects are there. Okay, so this is the features of a accurate beam balance. Then up to here it's clear now. We are using a common device which is called beam balance in order to measure the mass. Now you know what are the steps to measure the mass. The steps, first one is that make sure that the beam balance is accurate. How we will check the beam balance is accurate or no? We will check the pans are empty. When the pans are empty, the beam should be horizontal and the pointer should be vertical, so that it is clear that this is accurate. After that, we will keep one side weight to be measured. That means 1 kilogram or 2 kilogram or 500 gram. Iron bar we will keep on one pan. The other pan we will be adding sugar or whatever, rice or whatever you want, vegetable or something. You will keep it the other side, so that when they are coming horizontal and vertical, then that will be equal to 1 kilogram. This is the method how which we are using beam balance. Then nowadays, this is the earlier system. Nowadays we are having another one equipment, electric weighing machine. Have you seen that one? Now when you are going into the shop and you can see that a steel pan will be there, and they will be just keeping the materials on that pan. Suddenly there will be a display, will be the LED display. There they will show how much kilogram. If it is 1 kilogram, we need this will show 3 more digits. Okay, sometimes if you are measuring, you can say that this is 1.002 grams. That much accurate we will get. This one was not that much accurate compared with the electric. Electric means even 1 gram is measured. Milligram. Okay, even milligram is also measured. Clear now? So, like that we are using nowadays, we are having electronic weighing machine. So, these days electronic weighing machines are also used for measurement of mass. The machines display the mass of the object directly on an LED display panel. There is no need to have standard weights. What is the benefit of this one? We don't want this 1 kilogram or 2 kilogram iron bar, we don't want. Okay, we just give the things what we have to measure on the pan. Suddenly there will be a sensor will be there. Through that sensor, it will automatically measuring the mass of that object, and it will be showing that in display 2 kilogram is the mass of the object, or 1 kilogram is the mass of the object, or 1.125 gram is the mass of the object. Okay, so that nowadays we are having electronic balance which is advanced and it is very accurate. And one more thing, you can just look at the page number 25, figure 3.13, a physical balance. A physical balance. What is a physical balance? In a science laboratory, accuracy of the utmost importance and therefore a modified and highly sensitive version of the beam balance called physical balance is used. For example, now we are not using physical balance in physics. Normally they are using in chemistry. In chemistry laboratory, when they are performing some chemical experiments, they need exact maybe 2 gram of chemicals or 1.5 gram of chemical, like that they need. So for that they will be using a physical balance which is very sensitive and very accurate. You can see that physical balance is kept inside a glass jar. Is it not? Physical balance is kept inside a glass jar. Why? Even when we are breathing, some air will be going. That can be some deflection on the physical balance, because physical balance is very sensitive and very accurate. Okay, and if there is no glass jar, our breathing time, that air can be touched there, or if a room is having some fan or something, that wind can go and touch on the fan of the physical balance, then suddenly that pointer will start deflecting, so that the value will be changed, because that is very sensitive. Okay, so this much regarding our chapter measuring mass. Okay, so what you have to do, you have to read it very well, and if there is any doubt, you have to ask me. Okay.